So I give another couple minutes before I start with the introduction of the session today, and then yeah, give it to the first session. All right. So we can maybe slowly start with the introduction. Welcome, everybody. This is our first installment of the series we wanted to have regarding the webinars and tutorials of particular specific outcomes, to go more detail into what they are and what can be done with them in practice, and also answer your questions, those things. And the first one is about domain ontologies, and particularly with bridge concepts and how we can align different ontologies, basically, from different levels, with the help of this concept, which was developed in the context of OntoCommons. At the end, there will be again refinement of several bridge concepts aligned across OntoCommons project. I'm hearing a lot of background noise, so if you could mute yourselves would be great when I'm talking. Yeah, thank you. Yeah, so you could also basically be part of the process of developing or recommending basically what are important terms, what are important concepts and relationships on domain, by helping us out with some requirement collection, of course, at the end. But the main focus of today is to bring some more practical aspects of the products that our technical work packages in OntoCommons actually have produced. I am still hearing a lot of background noise.
Right. I believe that you can mute people as well yourself as an organizer presenter.
I'm not sure if I am the organizer, so this is the issue. But Arko, maybe
I can make you a host too.
Okay.
Yeah.
I think it's the best way, because people might not be noticing that they are.
Yes, that's true.
Yeah. I didn't notice when I joined this call.
Yeah, I was actually looking for the option to mute mute people.
Okay, I have made you host.
All right, great. Okay, great. So thanks, Arko, Katerina. I briefly just introduced the agenda today, and then we can start with the first session. So we will first give a brief introduction. So this will be given by Lan Yang. The introduction to OntoCommons ecosystem, ontology stack, particularly for cross-domain interoperability, for half an hour, and then we will have a question answering session. And then we have introduction to alignment of ontologies through bridge concepts, their motivation, rationale, and development process based on the initial input from initial demonstrators, will be given by Francesco from University of Bologna. And then we have a hands-on session using OntoCommons ecosystem ontology stack for your applications. This will be conducted by Arko and Lan again for 40 minutes. And at the last session, we will have a introduction of the requirement collection task for the stakeholders interested in the project, who wants to participate in further development and refinement of domain level ontologies and bridge concepts for the domains that you are more interested in or you're active in, regarding like materials, manufacturing, etc. Yeah, without further ado, I will give the stage to Lan, and she will start with introduction to OntoCommons ecosystem ontology stack.
Thanks, Umut. Can you see my slides? Is it in presentation mode?
Yes.
Okay, perfect. So, hi everyone. I'm going to actually introduce to the current status of domain level ontology alignment and harmonization. So we called it the OntoCommons ontology stack for cross-domain interoperability. I will mainly cover the three topics. So first, I will introduce the domain level ontology harmonization activities. Basically, what we have done is we did a domain coverage analysis in 5 focus areas, and we also developed some bridge concept to enable domain concept alignment. And the second part is I'm going to give you a quick tour of the industry portal. I'm going to point out what you can find on industry portal and basically how to use the industry portal to find domain level ontologies. And the last part is some supplementary resources to the OCES ontology stack. We have a repository on GitHub, which hosts the TRO, a top reference ontology, and MRO, the middle reference ontologies. We also have a domain level domain ontology catalog, which listed the domain level ontologies discovered from the landscape analysis. So to begin with, I'd like to start with the domain level harmonization activity. So we have done several analyses in about domain coverage. So these are the 5 focus areas that we have in terms of the domain level ontologies harmonization. We have systems engineering, product and service, materials science, manufacturing, and maintenance. So basically, the 5 focus areas has carried out separately some domain coverage analysis and some bridge concept engineering activities. So in terms of systems engineering, so in this focus area, we actually just found a very limited number of ontologies. And among them, we found like IOF systems engineering ontology and the GoPre ontologies, which are relatively mature. So the IOF SE ontology is proposed by the IOF SE working group, which is motivated by the use cases in systems engineering, systems architecture, system lifecycle, and model-based SE systems engineering. And the GoPre ontology provides the meta models that supports various model-based SE formalism across lifecycle stages. We also found some formal specifications related to systems engineering. For example, the ISO IEEE IEC standards and the SE book and OML specification. And in product and service focus area, we discovered the PSS ontology, Pronto, IT service management ontology, etc. So the PSS ontology is a basis ontology for enhancing the engineering of product service system in manufacturing. And it models all the aspects that affect or potentially affect a product service system. And the product ontology or Pronto is an ontology for product modeling domain. So it manages the features that could be considered to be taken into account in a product representation. And then the IT service management ontology, which as I mentioned before, provides a formal vocabulary for describing the resources related to IT service management subjects. And in materials science domain, this is a relatively large domain, we actually found the largest number of domain level ontologies. They are categorized by subdomains and disciplines, and also categorized by like top level ontologies. For example, we discovered like AML-based ontologies, BFO-aligned ontologies, and other like SUMO-based ontologies and SIO-based ontologies. So it kind of categorized them further by subdomains and top-level ontologies. In manufacturing focus area, we identified, for example, the GRACE ontology, the SEREF extension for the industry and manufacturing domain, the SMDL, etc. So, for example, the GRACE ontology is designed for considering the particularities of home alliance domain and integration of process and quality control levels. And the SEREF for industry and manufacturing ontology is created to align initiatives in smart industry and manufacturing domain in terms of their modeling and standardization. And we have the MSDL, which means the manufacturing service description language, is OWL-based ontologies described for to specify the service description. And last, we have the maintenance focus group. We discovered like roaming, IOF maintenance, IMAMO, and CHAMP maintenance. Some ontologies in manufacturing related domains also include some concepts and classes about maintenance, but those ontologies are not shown here because this focus area is only like focusing on specific domain ontologies of maintenance. So all of these ontologies that I mentioned have been documented in the first report on harmonized and developed ontology, and you can find a complete list of them. Many of them also have a link attached for indexing purposes or downloading purposes. And Arco has made them also available on industry portal, except for the ontologies which are already existing on the MAP portal. So we don't duplicate them again in the industry portal, but you can find many of them both on the industry portal or the MAP portal. And the next thing I want to briefly introduce is the bridge concept. So after we identified the existing domain level ontologies in the 5 focus areas, we try to align some of them using the bridge concept. And this template is used for bridge concept engineering. So basically it tells the information about the concept, and it presents the concept elucidation. It contains the related knowledge resources, either the definitions about this concept or some traits or features about this concept. And then the last part deals with the alignment, both vertically and horizontally. So I'm going to show you a quick example through my slides, but Francesco and Arco will talk about the bridge concept in more details later on in their presentation as well. So we managed to produce 12 bridge concepts spreading all over the 5 focus areas. If I take this part, bridge concept part, as example, so the part, we mean any manufactured material item. So we analyze the different definitions and terms that are used in the knowledge domain. For example, you can see part is also referred to as component, as item, spare part, piece, and sometimes it's referred to as product. So these definitions were analyzed and summarized in the form of a list of traits in the end, in the second part of the bridge concept template. And these traits helped to define a concept elucidation about this bridge concept part. And then we show how the bridge concept part is aligned to the middle level concept commercial product, and how it is defined in different ontologies. For example, in the X-row ontology, It uses the concept item from the serif extension. And in Mason and MSDL, they both have a concept part. And in IOF core, it defines materials components as the same concept as part. So these concepts and ontologies can be aligned horizontally using this bridge concept template, and we can somehow achieve a domain, interoperability to some extent. Again, Francesco and Arko will talk about the bridge concept in the following sessions to help you understand how they are generated and used. So I would just stop here and leave the details to them. So my next topic is about the industry portal. As I said, during the domain coverage analysis, we have discovered several ontologies, and they are mostly available in the industry portal and also on the MET portal. So here, maybe I should give you a quick tour on the industry portal website. So just let me switch my slides to my browser. And I need to share the browser with you. So this is the homepage of industry portal. I hope you can see my browser, just double check. Yes, so this is the homepage of industry portal, and there are several tabs on the top which provide the functions that you can use on the industry portal. For example, the ontology tab, if you click on the ontologies, it shows you the list of ontologies that are hosted and included by the industry portal. You can also search a specific concept. For example, let's try the bridge concept part, which I just showed. So if you type in a string here, for example, the text is part, and it listed all the ontologies which contains the concept part. And the next function is the mapping function. So you can actually select an ontology which you are interested in. For example, I choose the IOF core ontology, and I can see the mappings between the IOF core and other ontologies which are in the industry portal. And if you want to see some specific concept and their mappings to other ontologies, we can actually search for that class. For example, let's try system. And for example, I choose the system in the Mason ontology. And I can also click the mappings and see how this system concept in Mason be mapped to other ontologies. And if you click a specific ontology, it can show you like the mapping between these two ontologies and the concept which are mapped. Yeah, so these are like the features that I use the most on industry portal, and recently there is a new feature added to industry portal, which is this solo songs. So I believe it's a more visualized tool which can show the knowledge graph or the relationships between concepts. Basically, it visualize the ontology for you so that you can view and you can understand the ontology in a like graph visualization way. So that's the new feature on industry portal. Yeah, so I think I would just stop here and go back to my slides. So yeah, like I said, the industry portal provides several, you can say, functions or tabs on the website. So I just briefly showed you the browse tab, the search tab, the mappings tab, and you can also find the recommender, the annotator, and also it has a landscape tab, which visualizes all the data that are from the ontologies stored in the portal. So there are some good visualizations in the landscape tab as well. And using the industry portal, you can submit your ontologies. After submission, you can update your submission, and you can revise the metadata. You can change the ontology settings. And after submission, you can also review and editing the mappings of your ontology with others. And like I said, it also provides some visualization functions like the solutions. You can see your concepts in more like visualized way, and then you can see the mappings between ontologies on industry portal. So the last part in my presentation is I just simply want to point you to some resources that we have in the OCES ontology stack. So the first thing is the GitHub repository, which hosts the TRO and MRO. I'm not going into the details about these because I think the session is more about domain level ontologies today, but I just want to mention that because the OntoCommons framework contains like the pyramid shape of hierarchy, so you can also find top reference and middle reference ontologies in this GitHub repository. And also you can try this link, which is the domain ontology catalog. So it contains the ontologies that we found through a very big survey during the landscape analysis. And I think it's also, you can submit your own ontologies if something is missing here, and you can click by filling this form and submit the domain level ontologies that you want to be included in this catalog. Yeah, I think that's all from my side. And I can't see anything here, so I would just better stop sharing, and then, yeah, I can see the Zoom now.
Yeah, great. Thanks, Lan. So do you have any questions from do we have any questions from audience after Lan's presentation? I see one hand raised.
Yeah. I was wondering about that last link where you have collected all the ontologies. I
can copy it in the chat.
I tried it and it didn't work, but maybe I mistyped something. So
it doesn't work. I think sometimes when I tried once, I think like 2 weeks ago, it doesn't work, but then it were back to online again. I guess there was sometimes the server is down, so the catalog isn't accessible. But I will double check with Maria because it's hosted on the UPM server. Yeah. Anyway, I would just also copy the link to the chat. And
what's the UPM server? Is that like a company UPM?
It's a university.
Oh, it's a university. Okay.
University, yeah. Yeah, I tried, Katerina. It's not working for me as well. So maybe it's temporal, like server down or maintenance.
A central place for ontologies is, I think, really important. So hopefully we get it back up, or that would be really useful.
Yeah. You have the correct link, but yeah, I clicked. It's not working today. Sorry about that.
Maybe we could also put the link for the industry portal there.
Yes.
For now, like a replacement. Not entirely the same purpose, but still. Yeah. All right. Any other questions to Lan? Okay. I don't see any.
I have sorry.
Yes, please.
I didn't understand how the mappings were defined. You said that you could click on a concept and then you would find the mappings to all the other ontologies. They are mappings.
I think. Are you talking about the mappings on the industry portal?
Yeah, the ones you showed before when you chose a concept and then you could find the mappings to other ontologies.
Yeah, I think there is a basic, the fundamental mapping algorithm behind that. I think it's a term-based ontology-based mapping. I'm not sure because like I think it's better, Arko, you can help me to answer.
Yeah,
But my
can...
understanding, yeah, that like there is a basic algorithm that provides like term-to-term mapping, but it also have other algorithm that support like some kind of concept mapping as well. Yeah.
Just to add, yes, Lan is completely right. What you saw right now, the mappings are kind of lexical mapping, and they are provided by a tool called Loom, and Loom was developed by the biology community, and so it's basically a lexical mapper. However, what we are trying to do is that we are trying to input all the mappings, what we are creating part of the OntoCommons project, and we will talk about that in the next slides. But yeah, you can submit your own mapping there also, but what you saw mostly, I will say 90% are done, automatically by this Loom algorithm. Yeah.
So I have a question regarding to this. You said people can also submit their own mappings to Innsbruck. Did I understand right?
Yes. Yes.
Yeah. So
you have to have an account, and then you can submit your own maps.
Okay. So how this process exactly works? So do you have to approve the mappings, or it's just listed? So different kinds of mappings are listed under different categories or names.
Yeah, so it shows which mapping has been done by Loom and which mapping is done by like manual input. For now, so that kind of helps us to distinguish for now. But a new update is being developed, and it will be available, say, in next few months. So we are developing it to provide a complete metadata of mappings with the SSS OM format. Some of you know about this new metadata standard for mapping. Once it will be available, we can support a lot of other ways to categorize, contextualize the mapping, and then group ontologies according to them and stuff like that. Yes.
All right, thanks. Any other questions from the audience? You can also write your questions in the chat during the presentation, and we can address it later. Or, maybe if the speaker prefers, also just address it on the spot, of course. Yeah, but please also don't forget to use the chat option. Okay, if there are no other questions, then we can go to the next presentation. Which is the introduction to alignment of ontologies through bridge concepts, their motivation, rationale, and development process based on the input from the initial demonstrators. And Francesco Antonio Zatterini will be giving this presentation, I believe. Yeah.
Good afternoon. I think that Arko should do a brief introduction, then I take over.
All right. Okay. Because this morning there was some mail traffic I didn't really understand. So
no, it is you are right. It is mainly Francesco, but I'm just trying to make a small introduction to set up the concept before we rigorously go into the bridge concept and then lay it out. So where the bridge concept comes in, as you all know, that OntoCommons, the most tangible outcome of OntoCommons is the OntoCommons ecosystem, or OCES, as we call it. And what is OCES? OCES is a stack of ontologies from the top level ontologies to the domain level and even some application level. But also it contains the methodology for ontology engineering, ontology alignment, harmonization, and a lot of tools supporting the activities of that. So the bridge concept is our method to glue these different stack of ontologies, and that is its main purpose. However, it provides a lot of other benefit. For example, it actually comes down to even at the application level and the bottom and the domain level, when you use this, stack of ontologies, it can actually support you, guide you to have a logical mapping and then find out a lot of inconsistency. We will show it in the hands-on in the next session actually, but we have to we will lay out first that how these bridge concepts are being developed and what is their purpose, and really how we identify them. So yes, so for OntoCommons, we believe that we have many different ways the ontologies can be used. For sure, you can model your data, you can develop new ontologies. You can enrich your ontologies with other ontology. That requires ontology mapping. I will say the bridge concept will have some kind of effect in all three scenarios, but how we need to see it in the next presentations. So also, where does bridge concept comes in? So we adopt a slightly modified version of LOT methodology. So both for new ontology development and alignment of existing ontology. And the bridge concept kind of are first identified from the requirement we gather from our use cases, and also we kind of collect them into domain level use cases, and that helps us to identify the bridge concept, also identify the ontologies for which this bridge concept will help in alignment. So to show you where in the stack of ontologies the bridge concept comes in, they are mainly at the mid-level and the upper domain level kind of. This is where we try to develop new bridge concepts. And so the bridge concepts also require this requirement gathering, as Lan was talking about, these different ontologies we have identified and the bridge concept we have identified. I need to backtrack, and then I want to say that these were done through this fundamentally have got a lot of input from the requirement analysis. We will also talk about the requirement analysis at the last session, so I will keep it for that. Just to show you that these two process a little bit more, that how we identify this bridge concept is that what we get from our landscape analysis, which we did for many different domain areas, is a big list of ontologies which are existing. And we also have this competency questions, as we call it, as we get our requirement from the use cases, we try to identify which ontologies of these existing ontologies can have a more coverage, for these competency questions. And then if we have an ontology with a lot of coverage, then we identify it for the alignment. If we find that there is no coverage for any ontology for our set of competency questions, then we flag that domain is kind of require a new ontology development, and we flag it for some new ontology development. And then for these existing ontologies, what we identified in the previous step, that okay, we need to align them through bridge concept. How we align them is that we get a preliminary list of terms by running some kind of algorithm or statistical analysis, and Francesco will talk about that in detail. But then we get a preliminary list of terms which can be a potential bridge concept. You can say that which are mostly available in all the ontologies for that particular topic. And then we prioritize the bridge term from that list using, again, our competency questions. So the competency questions kind of also supply a glossary where we can maintain that which concept or which word or which term has the most occurrence in the competency question. So we identify those concepts as the most popular or like priority concept. So we kind of prioritize based on that. And then we start the development of this bridge concept using the bridge concept template and provide mapping, which Francesco will describe next. I think that is all. And then I'll give the floor to Francesco.
Greetings. Can you hear me? Yeah, I think so. Okay. It's a real pleasure being here. I'm Francesco Zatterini from the University of Bologna. Today, I'm in charge of presenting OntoCommons bridge concept in the context of the OCES methodology. In my talk, I'll focus on practical aspects concerning how bridge concepts are engineered and how they support ontology alignment. Bridge concepts are designed both to deal with OCES-specific challenges involving scalability and pluralism, as well as to address well-known issues revolving around interoperability and usability in the context of semantic web technologies. To fully understand the bridge concept, two different yet related aspects have to be considered: their role in supporting ontology alignments and as a handle for human users, specifically tailored to meet stakeholders and domain expert needs and desiderata. Regarding the first one, they are engineered as ontology entities, classes in a vacuum, standalone, with no taxonomical relations. They attempt to be universal adapters or converters, minimal data pipelines capable of supporting and facilitating strong semantic alignments among a plurality of ontologies. Again, they can also be seen as a neutral downward extension of the TRO. As immediately upon creation, they are linked to all the TLOs via strong semantic alignments, making TLOs benefits accessible to everyone without the need for direct support from ontologists. When it comes to their second role, bridge concepts are akin to a practical dictionary tailored for ontology implementation, understandable by stakeholders and domain experts, with explicit connection to the core acknowledged domain resources and standards. It should be clarified from the get-go that we aren't making a super ontology or a meta-ontology or super standards. We're instead creating tools which establish a network of connections by design, taking practical choices aimed at improving the effectiveness of semantic technologies in industry. Notably, this avoids interoperability issues to emerge at the meta level. An interconnected network grows in a radically different way from a skyscraper with a shaky foundation and conflicting parties. Let's take a closer look at how bridge concepts establish connection among the ontologies. It's quite simple. The bridge concept is connected with a specific classes from the target ontology with semantic relations such as that of class equivalence or subclass. Ideally, both the closer subclass and superclass are individuated and disjointness specified. This makes for maximal informative links. Given connection with multiple ontologies, bridge concepts become pipelines, moving in a figurative sense individuals from one ontology to the other, thanks to the taxonomical relations transitivity. These simple connections spread the reasoning downwards and make data sharing possible. So there are both vertical and horizontal aspects in the resulting connections. Notably, bridge concepts allow to deal with scalability issues in two different ways. First, we don't have to connect all the classes in all the ontologies, as connections spread with minimal losses of information if core nodes in the network are picked. A plurality of bridge concepts act as a sort of zipper, linking two ontologies together and ensuring that ontologies make sense. alignment makes sense. Again, this is not uncommon practice, but the OCES provides added benefits given the mappings among TLOs created by the consortium. Second, an hub and spoke structure is established, as all the ontologies are connected to the bridge concept and not one to the other. That's a move from exponential to linear, and its importance should not be underestimated. Here is a more concrete example of how semantic alignment among two ontologies can be locally established by a bridge concept, and how information and reasoning flows from the resulting framework. In theory, all the ontologies benefit from such an alignment. Among lower level ontologies, specializations and complementarity are especially important, besides the obvious points regarding the possibility of exchanging data regarding the individuals. Now, let's distinguish between formal and informal characterization of classes. The first are ingrained in the ontology and pertain to the hierarchical structure and mathematical aspect of the ontology structure. The informal characterization, for lack of a better term, instead pertains to annotation, intended and actual use of the ontology. Labels, when not confused with IDs, stay on the informal side, but we can be pragmatic about this distinction. Since bridge concepts are engineered standalone, they can only be characterized at the informal level. In fact, they also have to operate at this level to bridge between different ontologies. In general, the core challenge in semantic alignment is that different ontologies provide different formal characterization for concepts, which cover the same individuals, or whose extension could otherwise be compared. For all practical purposes, the goal is matching extensions, that is, making it so that the individuals which are classified in a certain way in an ontology end up in the class they would naturally be put into in the other. Anticipating bridge concept aim at connecting different formal characterizations in a way which maximizes benefits and minimizes possible harms. So some loss of information and accuracies for borderline cases is to be expected. Here is a template. We have already skimmed it through it in the previous presentations. It incarnates the second role of bridge concept as a sort of human interface. The template has many features. It acts as a guide in bridge concept engineering. It is hinged on fairness. It has parts dedicated to both users and ontologists, and is ready to be implemented in ontologies themselves. We will go over the specific structure if there is time. The choice of which bridge concepts are to be engineered is especially important given the previous points. The two roles are reflected in two desiderata. In fact, bridge concepts have to connect the ontologies at the right joints for machine interoperability to reap all the benefits, and they have to be accessible to industrial stakeholders and domain experts. Moreover, they have to be the one that stakeholders themselves need and want to employ. Otherwise, there is absolutely no reason for their existence. For that reason, we take seriously interactions with stakeholders via competency questions, among other things, and explicit connections are established between bridge concepts and standards, glossaries, or other knowledge domain resources which are particularly salient or well known for a given domain. That also ensures the reusability beyond the connection of a set of given ontologies which are to be aligned. To give some minimal insights on the background, focusing on pragmatical goals helps sidestepping meaningless discussions on semantics, labeling preferences, and fictional theoretical points, which might bring about fake stalemates. At this stage, it is really easy to be led astray by expectation of unity and determinateness. Yet the datum is that different stakeholders employ the same term in different ways, as it befits them. They have different stances on cases allegedly involving certain concepts, and they follow different standard definitions. It's Babel's Tower. Socratic questions like what is an industrial process and related following debates do not contribute to solving the practical problem of improving industry by achieving a desirable degree of interoperability via semantic web technologies. Given that, bridge concept engineering is guided by pragmatic pluralism. We take the tools that are useful without claiming that they are the correct one from a higher perspective. To reiterate the assumption that the issues can be solved and the goals met only by finding conceptual grains and by unifying the realm under a single banner is not enforced by the landscape and arguably unwarranted. In fact, even assuming that there was a right or overall better concept of, let's say, product or device, it would be meaningless if its use could not be enforced. Not only that concepts are rooted in needs and desiderata, and pluralism has its reason. Imposing a universal shoe size to all human beings would hardly be deemed a good fit of standardization as much as it would reduce manufacturing costs. So we embrace pluralism and a very human stance of fit rather than match, adjusted for communication with machines. I think we can go back to something more practical, that is the actual methodology for the selection of bridge concept candidate terms. Two methodologies were developed by the consortium. We have already briefly been introduced to the first one, so I won't really go into more details here because it's basically abstract mathematical instruments based on graph theory and network analysis. Moreover, it is still being consolidated, so showing the results is a bit premature. The second one is inherently manual and effective when few ontologies are the target. Their statistical analysis fails. The process is not particularly different, but there is a much higher reliance on experts' knowledge, and the process is more holistic in nature. I won't bother you with details unless you are interested. Again, it's not particularly different from any alignment among ontologies. This method has been employed by the consortium to align ontologies in product and service focus area, and I'll now provide an hands-on example. The specific alignment situation was very peculiar as we were dealing with only two ontologies and were joined by developers from both of them. Nevertheless, hopefully some of the consideration can be generalized and be indicative of our results. Here is a brief description of the two ontologies. We have already gone over it in the first presentation, so I won't really go back on it unless you want me to. I think we can move on, and since we are a bit late, skim through this part. The product and service area conceptual landscape is particularly interesting as it is undergoing significant changes. So it's a bit more interesting than other focus area, at least in my opinion. The changes are related to services taking over the center stage, a process also connected with digitalization. As a result of that, the relevant concepts boundaries are less clearly defined than usual, and more practical local laws make the variance all the more challenging to achieve interoperability. We can also expect stakeholders to interpret the gray areas at its suita. As per the test penalties, the priority was individuating bridge concept which can be employed to align the relevant ontologies. Other bridge concepts can be integrated afterwards, obviously. When dealing with only few ontologies, the first step is taking a look at them to decide from which side to start looking for possible connections. As you can see, PSS being based on UF core, which in turn is based on BFO, offers quite a lot of choice. The figure should speak for itself. If a connection cannot be made with PSS directly, classes from the upper level ontologies can provide support. Let's take a brief look at Pronto. So here it is, quite a number of classes, but definitely not as many. The architecture is mostly developed horizontally, so we can expect some trouble providing full alignment. There won't be many shortcuts. That is, bridge concept providing a connection, maybe weak, but a connection with many classes at once. Once its preliminary analysis is complete, we investigate how the ontologies operate in practice. In this case, we were working with people from Pronto, so that was a non-issue. We were provided with a schema. Here it is. From there, we followed up with an analysis of the ontology and how it works. I don't think we have time to go into the details. In general, that led to a first list of candidates, including also terms for which the resulting bridge concept will tap in as alignment per se, but could also be useful given the inclusion of other ontologies in the OCES. I think we don't have time to go into more details, but once a candidate is identified, the process proceeds iteratively to pin down the most useful proto-bridge concepts. That involves a preliminary analysis of the landscape and of stakeholders' desiderata, and the subsequent formulation of hypotheses. Negotiation also plays a role when the relevant parties take part in the alignment. Consideration regarding which other bridge concepts are available will be engineered should not be disregarded. And finally, as it is being anticipated, sometimes it's better to engineer bridge concepts supporting weaker semantic connection, but more natural for users. So the analysis proceed. I will just make a summary at this point. The analysis proceed by identifying some connection in the landscape analysis, we analysis of ISO standard, etc. Afterwards, we analyze the classes, the specific ontologies, and try to find out how they are used. That leads to the formulation of some hypotheses, starting, we obviously start from the simplest cases. And from this hypothesis of alignment, we create a list of bridge concept or tentative bridge concept, which could be made to be a bridge, an effective bridge concept, depending on the outcome of whether the hypothesis is found out to be correct or not. In this case, we made, for instance, at the first stage, two bridge concepts that were aligned with equivalent class and subclass relations. And we went from there analyzing whether there were good connection or connection which could be employed in different ontologies, whether they were really close to some ISO standards or not. In this case, they were. So I think I can conclude here my presentation, and if you have questions, I can answer them afterwards. Many thanks.
All right, thank you, Francesco. There are some questions in the chat. I will come to them while it's still fresh, and then I have one question regarding the part in the introduction to Arco, but this can wait. So let's start with the question from Patrick. So he asks, because there was another question from Juan Yu, but I think this is already answered in the chat. So if someone's wondering what the question was, you can take a look in the chat really quickly. Yeah. Patrick asks, so he agrees with the need for pragmatism, but how would reasoning involving bridge concepts work if the focus is on informality?
In reality, it is not a focus on informality. The bridge concept elucidation is meant for human, but afterwards the semantic relation are strong semantic relations which are for machines. So in practice, we divide the bridge concept in those two roles. The elucidation is made for humans. It makes use of the fact that even with fit rather than match, we can have communication between humans unless you have working in some really borderline cases. If the concept is really well defined for a specific domain in a way which makes also clear which points are, which choices are made with respect to some ambiguities which could be arise and are checked by making, for instance, well, we consider what points are ambiguous between different ISO standards or standards in general, or we consider the competency questions, which points in which points disagreement occurs between different stakeholders, and address them, making choices. Obviously, a choice has to be made. We make a pragmatic choice, and then we connect, we show how they would relate with different choices. Once we have done that, which is the more human side part of we deal with a more human side of part of the bridge concept. We create strong semantic alignments which are made in a way which should ensure that they are maximally informative and they reduce the risk to a minimum. Obviously, that's a principle which cannot all be. It's a matter of trade-offs. If you want more connections, you will be expected to have more problems possibly arising. That also depends on which domain you are considering. Again, I want to reiterate, normal communications problems usually arise only in borderline cases, but borderline cases are borderline cases. They are not the standards. So that might be a way to go around.
Okay, thanks. So what I understand is that the bridge concepts basically have two faces. One face looks to humans and the other face looks to the machines, and depending on the, I guess, skills and the need of the adopters, they could use both with different levels of, let's say, computational power and expressivity in a sense.
In general, there is an handle for humans, and then everything else is for machines. The underlying assumption is that the humans are the one which decide whether certain individuals fit in a class rather than another. That's an assumption which might not be correct in a few years, but for now it's mostly synthesized. Yeah.
Okay, thanks. There is one more question from Gerhard. I think it's also somehow like related to what Huang Yu was asking. Maybe I first then reiterate what Huang Yu was asking, and then come back to that. Do you mean you have run some algorithm among domain level ontologies to identify candidates for bridge concepts? If so, will you consider to provide mapping information between domain ontologies, concepts, and bridge concepts via industry portal? And
I think this is a question for Arko. Yes.
Yeah, and Arko's answer was, so this is exactly the goal. So yes, I mean, short answer is this. And there's also a longer answer you can read in the chat. So the Gerhard's question was also, the first presentation given by Arko showed an ontology alignment algorithm as a first step. Is that step skipped for now in the OntoCommons ecosystem in favor of informal approaches? And if ontology alignment algorithm, which are the recommended ones? So,
given the focus areas which were considered and the number of ontologies, the first step has not really been investigated unless at length for the time being. We were thinking about using standard tools for ontology alignment, semantic tools, automatic semantic tools for ontology alignments, but we haven't really considered specifics about the algorithm beside on paper. That being said, it's possible that a pluralistic approach might be needed because different domains and different circumstances might call for that. That said, I don't think that it is impossible to find some way to make it work. Obviously, that's a question more for the mathematicians than me. They recommended, well, to provide some general recommendation about the alignment algorithm, since the alignments have to be really only tentative at the first stage, we would employ some automatic tools with really low bars for entry, and then refine them in a second stage, or depending on which alignments are consistent one to the other, the mapping is among top-level ontologies, which in this case can really help, and some other considerations, which are, well, it is semi-automatic for that reason. Experts can refine the first list of candidate bridge concept terms if there is a need for that. Obviously, if let's say 200 ontologies are considered for a specific domain, that becomes absolutely unfeasible for manual alignment. So semi-automatic tools have to be considered one way or another, at least in my opinion.
Okay.
And just to add that, yes, I mean, as Francesco explained, that for a huge number of ontologies in the domain level, we have to use some kind of ontology alignment algorithm, but it is not set in the stone. I mean, and I will say also that some kind of manual investigation needs to be always there. Also, there are some, I mean, statistical method we use for the mid-level ontology, because at the mid-level, we do not use alignment tool because the number of ontologies are much less than the domain level ontologies. But yes, for the domain level ontologies, because of the huge number of ontologies, some kind of alignment tool may be really useful. I will say for the recommendation, it always changes. There is a competition happens every year to find the best automatic alignment algorithm. However, some of them are not usable because they are really made in not any like for a public distribution as such. But in that case, I will say LogMap and then Align API, and then all of these are very much like popular and okay to use.
All right, thanks. Any other questions before we continue? or well, if the questions are not answered also, please, you can always follow up. But I think they were quite extensively discussed, the existing questions. So I would say, I mean, we are time-wise, we are quite good on time, and we are already 1 hour in. So I would say we give like a 5 minutes coffee break. Is that okay for everybody?
Yes, I was going to mention about that.
Yeah.
We should have some break. Yeah.
All right. So let's have like a 5 minute coffee break and meet here at 3:10. All right, welcome back. Well, important thing is if Arko and Lan are back, of course. Yes, but I think Lan is here. Yeah. All right. And Arko is also here. Great. Let me plot the agenda again, also give a last couple seconds for the participants to come back. Yes, so now we have the hands-on part, and I will again leave the stage for Arko and Lan. But before we start, so do the participants have to do some preparation for this? Should we give some time for that? I mean, maybe you already have this in your slides or your tutorial material, but
I did not plan that, I mean, or expected that people will really try them on their own, but I am actually sharing the GitHub, which is public, and everybody can download whatever I am showing here. However, I mean, these ontologies need some type of setup in Protege, and I will talk about that. But if someone is interested to really do it hands-on on the site, I mean, of course, they are welcome to do. And if any question after the session, please write me back, and then I can help you with that.
Okay, so because I mean, from the time perspective, since we are a little bit faster than we thought, which doesn't happen very often, so I was trying to be creative with with the hands-on part. So if anyone wants to, I mean, this is not a mandatory thing, it's not like a homework or anything, but if anyone wants to do it on the side while Arko and Lan also doing hands-on in front of you, feel free. I think you have the GitHub repository already there, or you can watch them doing it and try yourself later. And if you have any questions regarding this practical part, you can always reach out to us later, to me or to Arko and Lan directly. All right, then please proceed to the tutorial.
Okay, so this is the first tutorial we are planning kind of extensively. I mean, we will try to expand on the experience we will have here, and then have an extensive hands-on and with some physical presence in the Oslo workshop, which is coming. So please give us input after this. The tutorial, what we try to do is that, of course, this contains the basic development of ontology, because I thought, I mean, we thought that it will be interesting for the demonstrators to see how you can really use ontologies. So first of all, some basic knowledge of ontology and reasoning and familiarity with the Protege framework will be helpful, but not necessarily. I mean, you can just watch and then see the connection there. So as I was saying, it is only involving some application level ontology with a little bit of domain reference and the mid-level concept. We will not talk about any like rigorous top level modeling. However, for our top level reference, we used only BFO in this sample case. And we consider IOF core and SARF as the reference ontology where we will work mostly. So BFO is just for making things in sync with our OCES stack, what we presented, that it is always has a TRO at the top. So of course we have BFO. But we also have multiple top-level ontologies and alignment between them. So the OCES stack is also possible where you can use multiple top-level ontologies or domain ontologies which are linked to multiple top-level ontologies, which are more complicated scenario. However, in this demonstration, we try to focus on the bridge concept mainly, and to show that how bridge concept can help when you are in the data interoperability. That is why we are not covering some of the ontology development specific formalities, for example, annotation, metadata, encoding, also evaluation of the ontology, which is extremely important. But we will also, just mention them very briefly, that where you need to concern these steps. So let us go to the first slide. This is our use case, and this use case is not from any demonstrator. This is an extremely simple use case to be kind of domain neutral and also keep things simple, so that we can really understand the role of the bridge concept. So this can be a typical IoT data where we have two temperature and turbidity sensor, one temperature and one turbidity sensor, and they are monitoring the water quality in a fish tank. But you can clearly, imagine this use case in terms of something in the industry and material science. In material science, you need to do experiment. In industries, there are a lot of sensors involved in the production line. So the use case really wants to know, I lost my slide, yes. So the use case really wants to know that when the turbidity reading is more than 200 is considered, when the water is becoming unsafe, so they are trying to monitor it. For a first step, for sure, we need the data and the use case, the scope of it, and then we try to gather the requirement from it. And then we capture the requirement in terms of competency questions. And you can find the competency questions here, very few of them in real demonstration use cases. There are many, many competency questions. We will show some of those examples in the last session, because that will be kind of more related to what we need to do at this moment and what we did regarding requirement analysis for our OntoCommons partner. Now, the competency questions serve two purposes. First of all, these competency questions will help you to evaluate the ontology kind of in the end, whether you really developed it as per the customer's requirement. But in the beginning, these competency questions also give you a set of terms which you need to model in your ontology. In this case, we can see there are sensors, different kind of sensor, temperature sensor, turbidity sensor. You need the depth, turbidity, this type of properties of the water. You need some concept regarding the measurement and the time where these measurements are happening or captured. So these are the terms we need for the ontology. Now here as I mentioned, that we are kind of following the LOT methodology, and these steps are kind of laid out in the LOT methodology. You can find more information on the LOT methodology if you go to their website. I think it is lot.linkdata.es. Now the next step is the ontology conceptualization, and we have to we have to model the ontology, but then we recommend that while modeling the ontology, you use foundational pattern. So for sure, in the beginning, you can think it very simply with some relationship which you can find from the competency questions itself. But then if we try to iterate through and then try to see that how these relationships can be generalized, then we can actually find the pattern slowly, with iteration. Now, once you find a pattern, it is also important that you apply constraints to the relation to really derive them formally. Define them formally. For example, here you can see that you define the turbidity sensor as like something, if it participates in a process, it is always a turbidity measuring process. So you are saying that turbidity sensor cannot measure temperature, very simply, and say the measurement value of a turbidity measuring process is will give you the turbidity value. So you can write this type of axiom. More rich axiom you write, actually it is easier for the ontology to be validated by reasoning, but also in our context by the bridge concept, because as you will use some upper level ontologies, they are linked to the top level ontologies by some of this bridge concept mapping. So if you write some of these axioms, they can be checked by the upper level axioms, and then you can find the problems beforehand. Now, of course, while defining this concept, you need to fix the ontological commitment that in which scope you are defining it. For example, here the sensor is defined for measurement, but of course the sensor can be found as a product on the shelf, or say some companies also produce the sensor as their product through some manufacturing process. But then those are different contexts, and those are not in our commitment. So while defining the sensor, then you do not need to think about that because it is not in your commitment. So fixing the ontological commitment beforehand is extremely important to keep things simple, and also you can develop your ontology faster. There is a tool I want to mention here because it is also recommended by OntoCommons. It's called Shock. So while you are doing this conceptual map, this ontology conceptualization, drawing some picture, you can actually draw this in this tool. You can find all the information there. You can download some libraries which kind of align with the draw.io, and then you can find all sort of a pattern where you can which you can use to model the ontology. What is the benefit is that if you use this tool and model your ontology, actually you can upload the drawing itself into the tool, and it will give you the ontology file itself in OWL. So this is one good thing about this tool. You can use it if you want. Now, to actually lay out this ontology, what we define for this particular use case, it will be later useful. So let us describe it a little bit. So it is kind of using the IOF core as the reference ontology. So it is always recommended that please do not make your ontology from scratch, always reuse ontology. Here we are using IOF core in this example, but then you can use, any other ontology. In the next slide, we will also show it how we model it in the SAREP. But then here, you can see that it is extremely semantically enriched. So what we say is that sensor is a iOS piece of equipment. So you define this term called sensor under, iOS piece of equipment, which always participate in a kind of measurement process. Once you have the process, then you can assign the temporal instance, which is the timestamp where this measurement is happening. The output of the measurement is an information, which in the terms of IOF is called measurement information content entity. If you want, it is not shown in this diagram, but then you can define your new subclasses for temperature measurement and the turbidity measurement under measurement information content entity. Once you have the measurement information content entity, you can see you can attach the value of the measurement. You can also attach the unit. We are not going in there to keep things a little bit simple. Now, you want to express that this measurement is actually for the temperature and the turbidity of the water, which is in the fish tank. And how you will do that? So you say that, okay, there is a material entity called water, amount of water, you can say, and then that has some quality called temperature and turbidity. Here we are using BFO quality, and then because IOF4 and BFO are already aligned, so you can easily use the BFO quality along with the IOF core ontology. And now you say that, okay, there are several ways to do that. You actually can use it, can use the BFO concept site to say that, okay, the amount of water is in the same site as the reservoir is. But to keep matters simple, you can define a new relationship called contained in, which kind of a sub-property of the located in, and you can also very formally define it as having the same site. You can actually define where exactly the sensors are located by defining two different sites, and then saying that these two sites are actually part of the site where the amount of water is. So if they are part of that site, they are inside the water. So you can create a lot of different type of reasoning to make your data semantically enriched. So this is one example. And then I'm sorry, I do not know why this is here, but I think I just meant to say that all of these ontologies you can find in the industry portal. To say this IOF core and the SAREP, they are already there. So yeah, okay, now you have the ontology. Now you have to model your data in the ontology. I'm sorry, I just missed one step. You have to encode the ontology. I say that Shock tool can automatically do it for you. However, it is a practice that people use Protege and other tools to encode the ontology. We are actually also developing new tools as part of OntoCommons. So I want to just show up that we have these two tools already there. One is called Sulosons and then Ocean. Among these two tools, Sulosons will give you a graphical interface to develop the ontology, and it is already connected to the industry portal. So if you find an ontology there, as these ontologies you can find there, you can directly go to Sulosons and then start using them. Okay, so just one slide for this additional concerns. So, however, we will not pay much attention in this demonstration, but while you are encoding your ontology, you need to make sure that you are developing it in a nice way. So we have a recommendation set called what we call OCES technical principle, and then we can, which says that, okay, how you should make your IRI, which is a resolvable IRI, and then all of the different scheme you should maintain there. The most important part is the metadata convention, that you should maintain a good annotation of your ontology, because otherwise the ontology will not be useful in the future. So you define the metadata of the ontology at the ontology level, at the document level, but at the same time you have to you also need to annotate the classes and the properties which you use, you define in the ontology. Also, if you have some mapping, which doesn't come here very often, but in this example we will show some mapping. This mapping metadata needs to be also there. So these are the tedious steps of it, which are not directly related to the development, but if you ignore these steps, the ontology may do work for some times, but it is not maintainable and it is not reusable. So we need to take care of them. Also, some other concerns this ontology technical principle talks about regarding language and expressivity, reasoner and prover, serialization format, versioning scheme, and development management and issue tracking, how you really can make good ontology project as such. And this is one example of how you can, to what extent you should annotate your term. This is what we consider a very good amount of documentation for each term, because it is not necessary that you go to this much extent, but then if you can do as much as possible, the ontology becomes much more reusable. Okay, now coming to the next step, you have your ontology, and now you want to load your data into it, and so we will also not show this step. I already have the ontologies where I loaded the data, but I will mention how you can do that. These are really developers' concern. So there are many tools which can help you. For example, if you have CSV, Excel, or other flat files, you can use OntoRefine, which is given by GraphDB. You can use it within the GraphDB or as a standalone tool. If you want to create a permanent middleware between your database, you can use some mapping language called R2RML, but there is also a tool called KG Creator, which is part of the Solosons, where you can link to the database. Also, you can load different types of files. For complex structure, if your data is in a JSON format or an XML format, some types of system design files are in very complicated XML. You can use this this query called XSparkle, which will help you to mix both Sparkle and sorry, I forgot the name, XQuery, which is for the XML query. Together into one query, and then you can load data very easily. But if you are not finding any tool which is actually helping you in your situation, you need to revert back to the generic tools. So for example, Sparkle query, and then you have to use it along with some programming library, for example, JNR, TFLib, OwlReady, OntoPy, etc. Okay, so now we want to show that, okay, we model the sensor data in the IOF code, and I will try to switch to this file here. Okay, no. Okay. So you can see that and this is the IOF code. So it has a complete link to the BFO, and you have the measurements. Here we loaded only one row of data to keep it distinguished from the next model we will show for SAREF. So we have this only temperature data, one row here. You can see that this temperature measuring process, which is a type of measurement process, and you have a temperature measurement process which happened in this time, in this particular time, and you have a link to the timestamp, which says that this is the timestamp for which the temperature measurement process happened. And it says that in this process, there is a participant, which is the temperature sensor. And then you have a specified output for this process, which is a temperature measurement value. And now, of course, it has some value described here. I did not, attach the unit to it, but you can attach it here with the list of unit from QUDT or any other ontology if you want.
I think, Arko, you haven't shown the protege on your, maybe it's on your screen, but we are still seeing the slides.
Oh, that is a shame. Okay, I thought I shared the screen, and
no harm in repeating the stuff in teaching. It's okay.
Now
the protege is on the screen. Yeah.
Okay. So I will quickly repeat what I said. So we just added one row in this model, which is done using IOF code, and IOF code is linked to the BFO. So if you are trying to see it in the GitHub repository, which I shared, you can find it in the sensor code.out. And so you can see that the temperature measurement process happened at this timestamp. So you have the timestamp value here, and then you can see that it has one participant called a temperature sensor, and it has a specified output, which is actually the temperature value, and it has the temperature value associated with here. I didn't add the unit, as I was saying, but you can add it. Now it describes what property is, describes the property called temperature, and it inheres in some amount of water, and that water is contained by some fish tank, and it is located in the inner area of the fish tank. So the inner area, you can see it is a BFO site. This inner area has two parts. One is which are also site, but one is at depth 60 centimeter, at depth 30 centimeter. So you can reason that these two sites are inside the water. Of course, you can go in way more detail. You can attach the actual depth and then link it to the depth property, but this is not important. Here we are not going to look into that. So this is with IOF core, and now coming back to the slide, we will show that the same thing, the same data, you can also model it with SAREF. Now, the question is, why should you do that? Oh, okay, the scenario is that, say for example, that there are two different organizations and they are modeling some different, IoT measurement data, and they are using these two different ontologies as their reference ontology. So one is using Saref, another is using IOF core, and now they want to exchange their data. They want to know that whether their data is interoperable or not. Now, but here we are using the same kind of data set, but you can think it may be some different values coming from a different different site. So I can also show you this Saref model, and this will be inside. Let's see. So yeah. So if you are seeing in the GitHub, you can look into the Saref sensor.ttl, which has data inside it. So here Saref, it is much simpler semantically, and that is one of the appeal here. Of course, there are different need to use different ontologies. If you want to really quickly just model your data, you can use it. Here, what the difference is that you can see that that the measurement process which you saw in the IOF code is not present here, and so you directly can attach the measurement to the sensor, and then here you can see that this measurement is actually done by the sensor using this Saref property called makes measurement. So this temperature sensor, which is at some depth, we didn't go into the detail of the modeling of site here, but we are saying that makes this measurement, and then in that measurement, Saref will allow you to attach the timestamp and the value. So definitely this is much more simpler, but then it is not semantically as rich as the IOF code. So you lose some semantic, but it gives you the freedom to actually model it really quickly. Now we will come to the interoperability part, where we will try to use some kind of mapping to relate these two data. But before that, let us also remember that we are guided by this bridge concept. And here I want to show you two bridge concepts, so which we will use here. For this use case scenario, you can have many more, other bridge concepts for the other, concept. But really two important, concept for this use case is, one is that the sensor and the measurement actually. So here we can see there is on your so on your left, it is what the bridge concept is asserted in the ontology. So this is the mapping we developed, and on your right you will see that due to this mapping, how the inference kind of figuring out new mapping. So this mapping is of course not at the level of sensor, right? Like this is sensor is kind of coming at the domain level, at the application. There is a bridge concept called equipment, and the equipment, which you can clearly see the bigger oval shape, but it is also kind of have this OntoCommons.eu, IRI. And what we are saying is that iOS piece of equipment is equivalent to this bridge concept called equipment, And SAREF device is a subclass of this bridge concept equipment, because the equipment can be many other things. Say, for example, a vehicle can be your equipment. So due to this, and as we run reasoner, you can see that, okay, so device is actually a subclass of piece of equipment. So here we found one mapping automatically. We didn't do it for this SAREF and IOF core. We found that SAREF device is a subclass of IOF piece of equipment. Now, another one is the measurement. Similarly, you can see this measurement. What we are declaring here is that IOF measurement information content entity and SAREF measurement both are equivalent to this bridge concept called measurement. And for that reason, of course, because both are equivalent, we can find that they are also equivalent. It's simple. Now, how this data interoperability will work? As you see that we can actually now, we have the bridge concept, we keep it in the background. Now let's see that in our data, say these developers are trying to map their concept, which are actually for the data. You have IOF temperature sensor. This is one example, and the SAREF temperature sensor. And then you say that, okay, IOF temperature sensor is a sensor. I mean, you can directly say it is equivalent to temperature sensor, or you do not need to use that SAREF temperature sensor. You can also write that, okay, it is a SAREF sensor. I do not know what they used, but then it is a SAREF sensor which makes measurement of some temperature measurement. If you do that, then automatically this temperature sensor individual, which is under SAREF temperature sensor, will become also a type of an individual of IOF temperature sensor. And to see this in reality, you can actually go into, and you can do it in both ways. So I will show you some of these examples. Let me adjust a little bit here. So here you can see that we are trying to say that, okay, we are trying to bring the IOF instance, the SAREF instance into IOF instance. So for the measurement, say reservoir water temperature, and we wrote this mapping axiom, which is written completely using SAREF concepts. And this is the cross ontology mapping what makes this data interoperable. And if you run the reasoner here, and you can see that it, along with this temperature measurement, it also brings all the SAREF measurement individuals under this IOF class. And you can do the same thing as for the sensor. I think it is here. Let me go to the material and piece of equipment and sensor, and you can see that it is automatically bringing the temperature sensor, which is defined in SAREF, in under this temperature sensor here for the IOF. You can also do it on the reverse way. I mean, you can bring the IOF individuals under SAREF, and that works. You have something here probably. Okay, so you have this SAREF measurement. You can see if you can see the pop-up as I hover my cursor. It is under SAREF. Okay, it is also here on the top. You can see it is a SAREF concept, and you have these SAREF instances for the temperature measurement. And as you run reasoner, because of the axiom, you will find that the temperature measurement value from the iOS actually comes here. Now, okay, everything looks good, but then how it actually helps you? I mean, of course, these mappings are, can help you to automatically classify them, but then you can use, you can actually exchange data. So if you have some data at the Saref side, by Saref side, I mean the organization who use Saref, to bring that data into iOS, you can also do that. You just need to write some Sparkle query to make that exchange possible. But then this is also important in this case, in that case also, that when you bring the data, this data will be verified by this reasoning that yes, you are bringing the right data. Now, you will ask that okay, it looks good. But what is the use of the bridge concept here? I have to say that yes, you cannot see the bridge concept actually working, but it is working. When you run this reasoner, the mapping, what it has with the bridge concept is really validating thing. And then I want to show it with an example that how bridge concept can help you in preventing some misalignment. Say, for example, some developers say that okay, at the iOS side, it said that okay, so I have this measurement as a concept in the Saref, but I have measurement process, measurement that sounds like a measurement process. Why don't I map it to the measurement process? And for a particular temperature measurement, it wrote this mapping axiom that Saref temperature measurement is equivalent to IOF measurement process, and then which has an output of, which has a temperature sensor as its participant. But then as you will run the reasoner, and I will show you in practice also, let me find the right one here. Here, say for this particular case, the temperature measurement, which is in the Saref, they are writing this mapping axiom that it is a measurement process, which is, actually a measurement process. So when you run the reasoner, you will find that it actually became inconsistent. And you can clearly see that how bridge concept is working in the background, and you do not need to go in there, but then you can clearly see that the reason is that because of this mapping, you are actually trying to link a BFO occurrent where it is expecting a continuant. So by this, by this reasoning trail, it is saying that okay, so temperature measurement has now instances which are actually BFO occurrent. It was expecting a continuant, and as continuant is disjoint with occurrent, this is inconsistent. So you can clearly see that that because it is linked to the bridge concept, this type of error can be prevented. Now I also show you that if you want to really exchange data, and then of course this requires real possibility, real tools to do that, and then of course these are the tools normally people use in the professional setup, and you can clearly use that. All of this what I showed in the Protege, you can use it in some kind of graph database. I'm using here GraphDB, but you can use any graph database. There are a lot of them. So here we loaded the sensor data in the IOF one, and then this default graph contains the Saref data. As I can show you that you can search for, let me adjust that. You can search, you can search the Saref data with its simple structure here, and then it will give you the Saref data here for the turbidity sensor values. And then say you want to exchange the data from this Saref side to the IOF side. So the organization using Saref to model their data, you want to bring that data to model it in the IOF completely. You do not need to do that. As I showed, that the classification will still work, and then you can infer the data from their graph database, no problem in that. But if you really want to take the data, you can simply transform the data where you select it with the Saref structure, and then you load it into the sensor data, IOF with this IOF structure. You can see that because Saref is very simple, but IOF is more semantically enriched, you have to use some extra instances. So this is the trade-off. The volume becomes bigger, but you get more semantic. So here only some blank node is used, and then you can load the data, and then you can select it from the same graph, and then you will get the same values which was there at the Saref site. Okay, it is repeating data, and I have loaded it already for a couple of times. Okay, I will stop here, I believe, and then ask. Let people ask questions, because I can see some chat going on. Okay.
Yes. All right. Thanks, Sakwe. Indeed, there was a lot of engagement in the chat. Let's start with the first one. So Alex asks, is there an ontology for bridge concept? So I'm not sure what that exactly means. Is it like a vocabulary to describe bridge concepts, or is it like a hierarchy of, or a network of bridge concepts? Maybe Alex, you can clarify what you meant.
If it, I can answer it, but I did not also fully understand it, but bridge concepts are just concepts. They are right now, as an organizational purpose, they are, some of them are grouped into an ontology file with the mappings, and they are kept in the GitHub, in the ontology stack, kind of, with a mapping. So they are basically one concept with a bunch of mapping. So this you can call this ontology file itself. But bridge concepts are just one concept. Each bridge concept is just one concept.
Mm-hmm. All right. Then the next question is if we could get the copy of the slides presented today. Well, in general, the material, I guess. Sure. Yeah. Let's think about the best way to do this. But what we could do is to maybe publish it on the focus group of Word Package 3, and then share the link with people on the mailing list. I guess that makes sense. Also to increase our numbers of members in the focus group as an option, as like a side benefit. All right, let's see. Right, so I'm assuming this GitHub repository you posted contains all the material used in this video, just in case like people want to watch it again and do it themselves at home. Yeah, all right.
Except the GraphDB part, because you have to install it yourself.
Yeah, well, I mean, you can use your favorite triple store for this. Yeah. And then Gerhard says, I don't know
maybe I can ask.
what he's referring to, but maybe Gerhard can, you can.
Or refine my question. Sorry, maybe a dumb question, but can you say again which were then in the end the bridge concepts? Here it was sensor, or was it
Equipment.
Equipment.
No, both. I mean, so we showed two bridge concepts. One is equipment, another is measurement.
Why did you not have, I mean, just asking, I mean, of course, equipment is kind of I would say kind of more mid-level, right? The sensor is maybe more domain level. Why did you not choose sensor as a? You can. I mean, at a domain level, you can choose sensor and then link to different ontologies. Yes, that is a good way. But I wanted to use something which is at the mid-level, and we actually already have these two terms in our list, so it kind of makes it. Okay. And then on the measurement, if I understood you correctly, what you're kind of saying is that the measurement in Saref is actually in the end turns out that in Saref the measurement is actually not a process.
No, it is not a process. It is not a process. It is a value, and
it's an outcome of the process, I think, right?
Yeah, the outcome of the process, and we align it to, by this bridge concept, it aligns to the IOF measurement content entity, information content entity.
Okay, so it's a kind of also in Saref, it's actually seems to be described as if it was a process, but or something like that. So that's kind of interesting.
Yeah, that is kind of it. I mean, these are actually the manual step of the bridge concept. You can see that. Yeah, you cannot. I chose it because it says there is one clause that the measurement achieves a task, like some kind of task. It achieves some task. It can be, I mean, talked from the process point of view, but yeah, it can be. I mean, that is, I mean, completely debatable. And then if we need to change, we can change. But that was not my point of showing it.
Anyway, thanks a lot. Yeah, I mean, forget about what else I wrote. That clarifies. I just needed to get my head straight around what you've done there. But that's great. Thank you.
All right, Gerhard, since you're here already, you also asked, isn't that a BFO problem? Again, without
yeah, well, no, it turns out it's a Saref problem, not a BFO problem. Yeah. Obviously, if you talk about measurement, then kind of Saref is a bit like, not so clear. Okay, yeah.
All right, good. And then Juan Yu asks, I guess this also goes to this direction of like if bridge concepts have an ontology. So is there any like a hierarchical relationship between bridge concepts so far, or are they isolated from each other? When you think about it.
It is the hierarchical way of presenting the bridge concept, you mean?
Yeah. So is there a taxonomy, like a clear taxonomy we have right now between bridge concepts? Okay.
I mean, yeah, I mean, they can be presented in that way. We didn't think about them in that way. I mean, one problem is that then it kind of promote people to use the bridge concept as a concept for their ontology modeling, which we kind of want to prevent. That bridge concepts are there to map the ontology concepts which are part of real ontology, whereas bridge concepts are just bridges. You should not tie your boat to the bridge, but to the shore, kind of. That is our idea. But yeah, I mean, it is a good idea to find the bridge concept for while you are developing it. I mean, and it is a good good way to represent them, we can think about that. Yeah.
I mean, on the other side
Francesco
also.
wants to add anything.
Yeah, maybe I can add something on that. Yeah, we considered some specific case to have bridge concept in a cluster. So a series of bridge concepts connected one to the other. This maybe can be useful, for instance, when some concepts are really important for a specific domain. So you might want to have a really close bridge concept one to the other, so that the one who's making the alignment really can pick the one which is the best one, and it is the most informative one. This may be the case, for instance, for product, but there might be other cases. Well, for the conceptual area around the concept of product. This again should not be the standard, because if you have the hierarchy between the bridge concept, you basically have another ontology. There is also a risk of compromising modularity, and we want to absolutely retain modularity, because otherwise the system simply breaks down. Well, at least it is really fragile. So that's something we want to avoid. Again, in some cases, we can have some minimal incompatibilities between certain bridge concepts. So you pick some ontologies and some bridge concepts, you make your ontology or your set of ontologies which works for you, and you cannot have everything. There were studies on this in the past, so it is a structure which works. Obviously, it depends on what you want to do with your ontologies in the OCES. So there is that. But in general, no, we don't want a clear taxonomy between bridge concepts. We want them to be standalone.
Yes, yeah, I want to say, aligned with Francesco, what he said, any organization, ontological organization we make or you make would be an ontological commitment also, which would impose your view of the world than people who, like, it goes a little bit against the pluralistic approach we want to have, and as you said, also harms the modularity. I guess that's why they are more like isolated, and people can use without committing too much in other people's point of view, so to say.
Yes, the modularity is very important. Well, this also brings another problem, is that, as Francesco said, like you do not need to use all the bridge concept. You can use some of the bridge concept for your case. But then this question comes, like, which bridge concept you should use, and for that we are trying to, come up with some kind of tool which can detect this type of, this appropriate bridge concept for your use case, and then it can tell you. Yeah.
All right.
That is a separate work here.
There is also a further argument for having standalone bridge concepts. Well, it's not really an argument, but a way of comparison. You don't know if anyone knows about that, but there is also studies with conceptual design content patterns. They've been studied in the literature. They're basically mini ontologies, modules of ontologies, which can be reused. Then again, since there are modules, there are many classes ones and relations, they make some commitments and they become less reusable. In some cases, they can be much better because, for instance, when you want to create an ontology, you have already made part of the ontology ready. So you basically commit to that part, to that module, and you don't have to recreate it. But if it is about aligning ontologies which are already there, it's probably better to have less commitments than more. So it's a case-by-case scenario.
Yeah. All right. I think we also slowly wrap up now the question and answer part. Maybe last questions if anyone want to ask something. And yeah, time-wise we're still good. All right. So I would say, and if there are no other questions, again, we knocked down another hour. So let's have 5 minutes break and then start with the last part where we introduce this requirement collection task and the purpose and what was done, I guess, before and what's going to be done and what the motivation and the purpose is to this requirement collection task. If someone wants to participate, of course, the instructions for it. This will be the last part. Then let's meet again at 4:15 Central European time. Yeah. All right. Good, then see you in 5 minutes. All right, we are back. So the last part of today is this requirement collection task we wanted to tackle, particularly to refine the existing domain-level ontologies that we covered in terms of the OntoCommons ecosystem, and also the bridge concepts that were developed. The first initial work was done based on the input of the initial demonstrators, and now we also want to bring in new demonstrators to basically have a chance to influence on what comes out basically from the OntoCommons ecosystem in terms of domain ontologies and bridge concepts. And then I give again the platform, the stage to Arko to do his magic. Yeah.
Oh, it actually also need some input from you, Umut, because you will be.
Okay, I stand next to you. It's okay.
Okay, so I mean, Katerina was asking this in the first question was like whether we are using these competency questions for writing Sparkle. Yes, that is the standard use of the competency questions. Here in OntoCommons, we are also using them, as I presented before, that we are using them to identify ontologies, measure the ontology, the domain coverage for those ontology, and also identify the potential bridge concept, and also kind of find out their priority in which we need to attack them. Specifically, because we want to really address the demonstration use cases, and the goal is that particular small like toy example I just showed, we want to do this for real data from the demonstrator. Now, everything starts from the requirement engineering, because we need to study these use cases, and we actually already did it one time for our initial batch of 11 demonstrators. I want to quickly summarize the process. However, this is the first phase of it. There is also some more analysis done to bring all these use case requirement into different focus group requirement for different topics. For example, the systems engineering, manufacturing, and all those Lan actually presented in the beginning. Those require some extra analysis, but this first phase is important in terms of the engagement from the demonstrators. So I want to quickly go through that how we collect the requirement. So we collect, first of all, in the first step, we collect, we prepare some interview question for the use case owner, and also schedule meeting with them. Now, for each of these demonstrator use case, we try to create a template which we call ORSD. It is also, coming from the methodology we adopt. It's called simply Ontology Requirement Specification Document. I will show you the document in the next slide. This document will capture the scope, purpose, functional requirement, non-functional requirement, the term, and most importantly, the competency questions for the particular use case. We collect it from the initial interview, and by analyzing and talking to the demonstrator, then we send it back to the demonstrator for their review, or the demonstrator or the case owner. Sometimes demonstrator has some partner as the case owner of it. So they go through the template, and then once they verify that it is okay, we take it and then try to extract all the terms from the competency questions, which we include in a glossary, and also kind of prioritize based on the top 25 terms which the demonstrator identify themselves. So here you can see that it requires the involvement of us from work package 3, the partners from work package 5, as well as the use case owner and the industrial partner, as case-to-case basis. So to go through the ORSD template, so this is one of the example from the existing one. It is from Techniker. And this is called tribological data, about tribological data, and you can see that it is clearly mentioned the purpose, scope, the implementation language. This actually lists down any existing ontology they are using or they intend to use, the end user for this use case and the intended use of this ontology, and then some of the non-functional requirements. For the functional requirement, this is actually a list of the competency questions, and I can show you these competency questions in a second. Okay, I probably need to change sharing, sorry. Yeah. So here you can see this spreadsheet kind of put together everything. So you have the ORSD UC template here, as I was showing, and you have the competency questions here. And it is extremely detailed. I chose it because of its like detailed competency question, but then not every use case need to go. Need to have this many competency questions. It really depends on the requirement. Going back to my slide. Maybe another point I want to mention. However, many people already know the competency questions are really comes in in some type of question format, which can be easily written in a query, either a Sparkle query or a DL query, or some type of other query, and it also needs to come up with an answer. So this kind of competency question format kind of act as like a testing cases. So once the ontology is made, you need to model your data in that ontology and then run this test to see that it is really giving you the answer intended. If you can get all the answers, then, or as many as answer required for crossing the threshold, then you can say the ontology has been passed. Slide. Okay, so now no, this is not the right. Okay, now there is so we want to do it, we want to collect the competency questions for the new set of demonstrator use cases. There are 11 of them, so we will make it open for them to participate in that. We identified 4 use cases for now, but I think more information Umut can give regarding their need and how they want to proceed with that. We will discuss that. I have the last item, that is that in this second version we want to also collect the sample data for testing and benchmarking. As you saw that we need to have data to really test what we are doing. I mean, it is very similar to what I showed today as a demonstration, that we need to model the sample data in our aligned set of ontology and see that they are they are interoperable or not. And the question comes like, how do we collect the sample data? For sure, the industrial partners have the concern regarding confidentiality, security, but could we solve them with some OntoCommons procedure and policies? And we are open to listen to you all and have your input on that. We want to make the data publish with a lot of fair metadata, with semantic annotation also. If it is possible, if such data can be published, then these data sets annotated with the ontology, with the interoperable ontology, will be a great input from OntoCommons project, because this can help further the ontology community to work on. And then it can, no doubt, as we said, it will help in evaluating and benchmarking our mapping of the existing ontology, as well as we have to develop 3 new ontologies as per in the work package 3, which really require this data for testing and evaluation. So yeah, the floor is yours, and then Umut can give his comment, and then we can discuss.
Yeah, I mean, I give maybe another comment, more like a question. So what is going to exactly happen to these requirements? I know they're going to be used in the domain ontology that we have in the OCES, and for the refinement of the meta-bridge concept, etc. But what is the plan for these things after the project? So, like, as a company, let's say demonstrator or not, why should I participate in this activity? What is in it for me? So this is the question.
Yes, I can say that, of course, as for this entire session, we kind of showed how this, how many activities, from starting from, identifying bridge concept in our landscape survey, that how we can measure the domain coverage of the ontologies, and also in the end, validation and evaluation. These competency questions and the requirements are absolutely necessary. For our demonstrator, of course, from OntoCommons project, if we succeed to build a great number of, as a sufficient number of, alignment among ontologies, especially at least if we cannot do entirely for the domain level ontologies, at least for the mid-level ontologies and some domain reference ontology, at least if we can really align them, then of course demonstrators will be benefited by using this aligned stack of ontologies, where they do not need to think about the alignment to the upper level, like top level ontologies. As I shown in your sample data, if you have those ontologies which are ready-made kind of interoperable, then you can use different ontologies which are much close to your need at your for your application, and they will be there because you saw that in that requirement document, where the number 3, where we collect this implementation language and existing standard and ontology. If you are using some ontologies in your project, already, then of course, if you mention them, once you mention them here, that comes to our radar, and then we kind of try to give some priority to that kind of ontology. And of course, you can see that, okay, for a certain domain, there are some ontology where everybody gravitates to, and then that kind of gives us the opportunity to know that which are those ontologies, and we try to give, try to map them with some priority. And so this will definitely, give them this kind of, formal set of ontologies, and that probably the thing. But if somebody has any other idea, I can say whether it is possible also.
Yeah. What I understand is then, so at the end we will have a set of harmonized ontologies and bridge concepts, basically, and the people who participate in this requirement specification process will have the chance to influence this alignments and harmonization, basically, at the end. Which at the end, considering the number of partners and associated partners, it's already quite a large consensus in many domains to have we will have a set of ontologies that has actually quite a large consensus on from different industrial stakeholders from different domains. Yes. So what is the best way to participate in this activity, do you think? It's open floor. I guess the question is now to Arko and the Package 3 people who work on this. But if others have some questions and recommendations, you're welcome. Should we follow a process we had like the initial demonstrators, or something like a more flexible, less formal process? What should we do? I guess not does it make sense to send out the competency question form and ORSD template to the interested parties, or should we do first send out these documents, and then if necessary, with some of the people who want to participate in this, we can also do individual meetings and interviews, etc. But Katerina, you want to say something?
Yeah, I'm just interested if there is inside this framework, if there's a set way of doing competency questions, or if it's a bit of a free form. Currently I think everyone's kind of doing it in a free form way, but has someone created an experience that actually, no, we need to if we do it in this way, or look at these things, then it will be helpful. For example, with our stakeholders, we always kind of case by case judging if they're setting competency questions that are too high level versus actual things they need to ask from the knowledge graph. So I was just wondering if there's anything there. If there's not, then that's fine. I'm just kind of wondering if there's more to share there.
It is a very good input, actually. This brings out 2 points. First of all, yes, competency questions are kind of, everybody does it in a kind of free form. And there is no harm in that, for sure. We are using the ORSD document kind of to formalize the process. And basically, this is just a template, and there is no no rule has been written, behind this template, which can, greatly influence stuff. Some benefit of that, yeah, you can divide them into sprint and then stuff like that. But really, any other format will be okay, I believe, no problem. Well, at the end, if you provide the competency question in any format, we will kind of put it in this template. That is a really easy thing to do. It's not a concern. The second point is that whether you want a high-level competency question or really questions regarding your data. And exactly this is, this depends on the need. So as I want to point to this very early slide I had here, if you can see that we are saying that, okay, there are many different levels of need, or different types of need to use an ontology. So Of course, you can say situation one where you want to document your data. You are not, concerned about, developing the ontology or as such. It is the data which you want to, which is your focus. Then probably the competency questions are much at the data level. But then if you are interested into developing a new ontology, maybe you can include some of the higher level questions regarding the semantic of the data. But then say you are not interested at the data itself. You are interested in data interoperability. So you want to really map ontologies, different ontologies, enrich ontology with the concept from other ontology where it is more related to the semantic, and then there the questions are completely different from the data specific competency questions. So yeah, you are right. It depends on the need of the use case.
Mm-hmm. But I mean, as far as I know, we did have some sort of structure in the first round, right? We did have the ORSD template. We did have this this structured Excel sheet. So there was some sort of formal, let's say, structure to guide people in a sense. So it wasn't like completely free, but we had.
And the ORSD template can work for any situation. I mean, it's like just a template, and you can, whether your competency questions are high level or data specific, ORSD template doesn't care that much. Yeah.
Okay. Mm-hmm. All right. Any other comments, ideas, or wishes regarding the collection of could be also based on experience? But what I see now is that it makes sense, I guess, to send out the necessary templates regarding competency questions and people who are interested in. So this could be obviously for the people for people who are already developing ontologies in these domains. It will be, I guess, more or less a low-hanging fruit, so to say, and for other people, demonstrators and maybe other stakeholders that are interested in this activity that are now today part of this session could also, of course, contribute. I guess, I mean, we can even distribute it in the all mailing list and demonstrator mailing list separately to reach the largest audience. In this case, I don't think there's a harm that we also get input from stakeholders that are not officially demonstrators.
No, I mean, but that comes in the extra analysis or after we get the use case specific requirement, we kind of club them or like kind of kind of cluster them into different focus groups and then try to expand them with the input from the stakeholders.
Okay.
But at the first step, it is required that the use case competency questions are exactly about the use cases, because then you can test that particular use case with those competency questions. About the new set of demonstrators, I mean, yeah, the new batch. I mean, we have to send a separate mail to them for their input. I think. Some work are already being done. I mean, Lan just left, I believe, to conduct interview actually. So we already started. I believe we need to now gear up with other demonstrator or whoever want to participate. I want to mention another thing about the last point, which is not only for the new set of demonstrators, but also the old batch of demonstrators. That we are requesting data, and then here I want to learn from whoever present here from our industrial demonstration, including Katarina, that what is their input on that, like how we can get some sample data, how to anonymize them or like use it for this kind of project here.
Well, like, what is the hurdles in front of it kind of for us? Yeah. I mean, the first thing comes to mind is obviously it's proprietary data, and not everybody wants to share it, that's fine. But other than that, I guess we need to also define what kind of data we exactly want. And so
any data. Seriously, it can be any data. Like it can be a spreadsheet. It can be data regarding. I mean, I am just remembering some of the old use cases. Maybe they are experimental data from from their experiments. It can be some plan and schedule they exchange, which are like not a big data, but it is very important. It can be also like some kind of model data, like say design data, or say system structure data. I mean, any data is okay.
I mean, so what I could discuss internally with our team is we have this, like, we need to do like a product safety report to authorities. And today it's a PDF and it's made manually, but we want to be able to generate the PDF from the large graph. So, because that's something to send to the authorities, that's not so proprietary data, because it's anyway kind of what we need to be transparent about. So I could discuss that with the team if they would be of interest of like working with this data, but this data is kind of, what we want to do is not to take that data and turn it into a large graph. That's not the point, but to, from whatever we have in the large graph, to produce this. So it's kind of a competency question in itself, this PDF, that kind of, can it be recreated from the large graph, or like a acceptance criteria almost. So maybe if that is something, but I need to talk to the team first. So maybe we can email about this idea of is this something to demonstrate the work.
Exactly, we can tell. I mean, here our goal is, of course, to get the data to actually model it. As you have a knowledge graph, and it is already modeled in the knowledge graph, and that is very good. I mean, we want to say that, okay, so look at this RDF graph. We have the data inside it, and then how can we link it to the interoperable stack of our ontology, and then it is kind of linked to some top level ontology, and we can run some reasoner on top of that, and then we can show that it is working as from our point of view. Of course, the later part is the use of this data, and then there you generate PDF and some kind of other document that is your use case for that particular data. And that is not in our scope, like say, yeah, for sure, like this data will be used, say, for machine learning, or say something that is a different purpose. We stop at where you have it already modeled, or you want to model it in a knowledge graph. That is where we are interested in. Yeah.
All right, so I recommend this. I mean, just to have an outcome on this, we set up a nice email with these points we discussed here. So what is exactly needed, like some sort of open call, people for us to help. So what the purpose, what is the motivation for them to be part of this activity, and what needs to be done, and yeah, what is our support mechanism basically for the people who need help. And start the process like this. And yeah, this call could include the data call also, like we need sample data. And I guess, yeah, we can also give examples as you just gave, like it doesn't have to be real data, it could be also simulated data, it could be observed data, like from sensors, etc., from IoT, anything. Yeah. So, okay, I think this would be.
There is a way to actually anonymize data. There are tools by which you can completely anonymize data, like say it will switch the numbers completely, it will switch the text completely, but it will keep the structure of it, and then that is kind of like meaningful, and then that is okay for us. And then
All right.
And then if we will send a mail, and then if anybody has any why question, we will send them this 3 hours long video link to watch.
Yeah, they can follow them. Yeah. All right. I think we can slowly wrap up if there's nothing else.
Yeah.
Any other general questions, feedbacks? Because we want to actually do until the global workshop, where you can also find more. I think the global workshop also will have a hands-on session where people also can do themselves there. I guess a little bit longer or more compressive, if I understood it right.
Yeah, we have. We are planning. I don't know if Hedy is actively planning for that with the organizers, but as I know, yes, this is planned from our work package. There is one session completely dedicated, but we want to also run something in parallel where people will be kind of dedicated for the hands-on session. So you can either listen to the speeches, but also you can go ahead, go with practical stuff where we can find some also like students if they can be involved in kind of like doing their project. Yeah.
But anyway, when the agenda is more concrete, we will anyway communicate all this stuff, what is going to happen. But there will be different, let's say, lanes of knowledge where people can participate and do things and knowledgeable.
Of course, Umut will let us work on that also. We can expand on this this small toy example to many different other things.
All right. And so like this webinar today and tutorial, this was the first version. We want to do maybe a couple more until the global workshop, and I will send around like a list of topics what we can do to prioritize basically the ideas. Today was the first one, as I said, and based on what you want, primarily what our demonstrators want to learn and what they want to know about, we will send the list of topics so they can vote and prioritize these topics, and we want to prepare 1 or 2 more events like this to go into more specific, in detail in more specific topics around OntoCommons ecosystem until the global workshop. And and the global workshop will be like a cherry on the top at the end with a larger scope and audience, and also in person in Oslo. Well, it'll be hybrid, but we hope people will join in person. It's obviously more engaging. All right. If nothing else from the audience, then we will wrap up for today. And the slides and the recording, I think recording is still going on, but so slides and the recording will be shared later. We will disseminate through the email lists you're already part of in the all at OntoCommons or the demonstrators at OntoCommons. So if you heard of this event, you will be able to get the access to the materials that we will share in the same platforms. Okay, thank you very much. Thank you for Arko, Francesco, and Lan. It was really great work from you and very intense stuff. And I know it's not very easy to prepare in a short time. And I really appreciate what you did. Also on behalf of everybody participating today, I also want to thank you again. And I hope you also enjoyed it, and hope to see you in the next event, whose topic will be decided by you. I feel like a television presenter, but it will be like this. And see you at the next event. And thank you very much for joining today.
You're welcome, Umut.
Thank you all. Bye.
Bye. Bye, everyone.
Bye. Thanks. Bye.
Thank you. Bye.